Welcome to What the F Happened, Fraud and Financial Crime Deconstructed, a Defend podcast where we break down what's actually happening across fraud, scams, AML, and financial crime.
Each episode cuts through the noise to explain the tactics, trends, and real-world impact behind the headlines, so you're better prepared for what comes next. Let's get into it. When you picture getting scammed or, having your financial information stolen, you probably picture a very specific, very human scenario.
Right, like a one-on-one interaction.
Exactly. It's like the person looking over your shoulder while you type in your peon, or maybe it's the digital version of that, right?
Yeah.
A hacker sitting in a basement somewhere, manually testing passwords or, trying to trick you into clicking a phishing link in your email.
Yeah, we definitely tend to think of fraud as this battle of wits between you and, well, another human being.
Right. And that human element is central to how we've historically understood crime, because there is always a physical bottleneck on the other end.
Absolutely. I mean, it takes actual time for a person to steal data, decide how to use it, navigate a website, and, process that stolen info into cash.
They have to type, they have to click.
Exactly. The attacker has to sleep, they make mistakes, and they just have physical limits on how many targets they can hit at once.
But consider what happens when you remove that human limitation entirely. Like, what if the entity trying to drain your account or hijack your transactions isn't a person at all?
Which is a terrifying thought.
It really is. Imagine an attacker that is just, a piece of self-executing code. No physical body, no need to sleep, and it has the ability to simultaneously test every digital lock on thousands of websites in, like, a fraction of a second.
You wouldn't even realize an attack had started before it was already over.
And the money was just gone.
Yeah, and that changes the entire nature of the threat. We stop looking at fraud as a targeted manual strike and start having to treat it almost like an environmental hazard.
Wow, an environmental hazard. That's a good way to put it.
Right, because when the attacker is purely algorithmic, the landscape of digital security transforms practically overnight.
And that brings us to why we're here. Welcome to today's deep dive. We are spending some time today looking closely at that exact transformation for you.
It's going to be a fascinating one.
Oh, definitely. We are pulling apart a brief but incredibly dense trend report from Forrester.
And it's titled Managing AI Agent Commerce Fraud.
Right. And it's a compelling piece of research because it isn't focused on, the phishing scams of 5 years ago. It is looking squarely at the immediate future.
Yeah, predicting how the tools we are building for our own convenience are going to be basically weaponized against us.
So our mission today is to explore this high-speed collision between automated convenience and automated crime, keeping you, the listener, ahead of the curve.
It's a critical topic right now.
It really is, because the core premise of the Forrester Report asks a crucial question about modern commerce. It asks, what happens when the entity committing the fraud is what they call a runaway malicious AI agent?
That phrase alone is pretty chilling. Runaway malicious AI agent.
Seriously. But before we get into how an autonomous piece of code actually commits a crime, we need to understand the baseline, right? We have to look at why these AI agents are authorized to operate in the commerce space to begin with.
Right, because we put them there.
Exactly. The report points out that AI agents are increasingly being trusted with 3 specific tasks. First, discovering products and services. Second, making e-commerce purchases on our behalf.
And third, performing consumer services.
Right. And the specific example they use for that last one is making restaurant reservations.
Which, those sound like perfectly benign, everyday tasks.
Yeah.
And they're meant to be. The whole goal is removing the friction from our daily chores.
Okay, let's unpack this, because I want to break down how that actually looks in practice. Think about, planning a nice dinner at home. It's one thing to ask a conversational AI to generate a recipe for, authentic lasagna.
Sure, we've been using language models for that kind of brainstorming for a while now.
Right, that's just text. But we are crossing a new threshold when you can say to your digital assistant, hey, here is access to my bank account. Go find the best prices for imported San Marzano tomatoes and fresh pasta across all local grocery stores. Buy them, arrange the delivery, and then...
And book a table, right?
Yeah. Book me a table for 2 at that exclusive Italian place downtown for next Friday. Think of this AI as the ultimate, hyper-efficient personal assistant who never sleeps.
It's a huge leap in trust.
It is. You are delegating actual financial agency, the ability to spend your money to a piece of software. So I have to ask, how does this shift where the shopper is an algorithm rather than you or me change the fundamental mechanics of e-commerce?
Well, what's fascinating here is that it alters the volume and velocity of commerce at a foundational level.
How so?
Well, when you or I shop for those lasagna ingredients, the process is incredibly slow, right? We open a browser, we wait for the page to render the images, we scroll, we read reviews.
We get distracted by a text message.
Exactly. We get distracted, we add things to a cart, and then we have to manually type in a credit card number. Human existence is just full of friction.
We second guess ourselves too. Like, I'll abandon a cart just because I don't feel like getting up to find my wallet across the room.
Right, we've all been there. But an autonomous digital assistant, it executes its parameters instantly. It doesn't need a website to render flashy banner ads or, nice typography.
Because it's not looking at the screen.
Exactly. It interacts with the store's database directly. It can scrape the inventory of 50 different grocery stores, calculate shipping costs, apply active coupon codes, and execute the payment in milliseconds.
Wow. Milliseconds.
Yeah. And the broader implication here is that commerce is shifting away from purely business to consumer or B2C. We are entering an era of business to AI.
Business to AI, I mean, that implies a complete redesign of how the internet even works.
It absolutely does.
Yeah.
The storefront isn't trying to appeal to human psychology or impulse buying anymore. It's optimizing to interface with machine logic.
That makes total sense. And I guess you see it with the restaurant reservations the report mentioned, too. Like, a digital agent doesn't dial a phone number and sit on hold listening to elevator music.
No, not at all. It pings the restaurant's booking system via an API and application programming interface. The machines literally talk directly to each other.
So it's seamless.
Seamless and instantaneous. But, and this is the crucial part, that exact removal of friction, the speed that makes it so convenient for you to get a table, is exactly what creates the massive vulnerability.
Right. Which brings us to the dark side of delegating our wallets to algorithms. Because if digital agents are out there making autonomous transactions at lightning speed, the sheer scale of global commerce just explodes.
This scales up massively.
And Forrester issues a very explicit warning about this new environment. They state that curbing fraud during these automated transactions is critical because, and I'm quoting the report directly here, runaway malicious AI agents can cause more trouble and losses faster than human fraudsters.
Yet that speed differential is the crux of the entire problem. It's what separates this from traditional cybercrime.
Here's where it gets really interesting, though, because I want to challenge that slightly.
Okay, go for it.
Let's look at the mechanics of fraud as we understand them today. If a human scammer steals my credit card info, they might try to buy, say, a few expensive laptops.
Right, classic fraud.
But my bank has fraud detection limits, right? If they see 3 laptops being purchased in 5 minutes, they freeze the card, they send me an SMS alert.
Yep, the standard safeguard.
So if a malicious bot tries to buy 10,000 laptops in a millisecond, wouldn't those exact same banking limits just block it instantly? I guess I'm asking, is the main threat here simply the speed of the AI, or is it the sheer lack of human bottlenecks that makes it so dangerous? Why is the speed actually a new, unmanageable threat if institutions have volume caps?
If we connect this to the bigger picture, that is a crucial distinction to make. You're thinking of like a brute force attack, where a bot just hammers one stolen credit card until it hits a wall.
Right, which the bank would catch.
Exactly. But a sophisticated autonomous attack bot doesn't act like a human scammer on fast forward. It acts intelligently to subvert the rules. It knows those volume caps exist.
Wait, really? So how does it bypass them if it knows they're there?
By distributing the attack, a malicious agent might compromise a database and extract 10,000 different credit card numbers at once.
Okay.
And instead of trying to buy a massive red flag item like a laptop, the bot programs itself to execute 10,000 individual microtransactions across hundreds of different websites simultaneously.
Oh, wow.
Yeah. It buys a $3 digital gift card here, a $5 software license there. Every single transaction is kept deliberately under the threshold that would trigger an automatic bank freeze.
So it basically just blends in with the noise of normal everyday purchases.
Yes, exactly. It looks like normal traffic. And because it operates autonomously and instantly, by the time a human analyst at the bank notices a statistical anomaly in the broader system, say, They notice an unusual spike in $3 purchases across their network. The bot has already finished the entire operation.
It's just gone.
Gone. It has executed the purchases, transferred the digital assets to a secondary market, laundered the funds, and deleted its own tracks. The loss is realized before the human defense even boots up. And that is exactly what Forrester means by more trouble and losses faster.
That is wild. And I imagine this applies to things outside of just stolen credit cards too, right?
Oh, definitely.
Like going back to the restaurant reservation example from the report, I think anyone who has tried to get tickets to a major concert recently knows the pain of bots buying up the inventory.
Oh, yeah. The reservation ecosystem is incredibly vulnerable to this.
Yeah.
A malicious bot could ping the API of every high-end restaurant in a major city, the literal second reservations open for the month.
Or scoop them all up.
Yep. It books every available table for prime dining hours using synthetic fake identities.
And then the human scammer behind the bot turns around and sells those reservations on a secondary market for a massive markup.
Exactly. And the restaurant suffers because they have empty tables if the reservations don't sell to real people. And the consumer suffers because they can't get a table without paying a ransom.
Right. And this highlights why Forrester uses the specific term runaway. A malicious algorithmic agent operates without physical constraints.
Not at all.
Like if a human runs into a hurdle, say a CAPT CHS asking them to identify traffic lights, they slow down. It takes a few seconds.
But modern malicious code is increasingly designed to solve or bypass those roadblocks automatically.
Yeah. It can spoof different IP addresses to make it look like the requests are coming from different countries. It adapts. It's autonomous, self-executing destruction. The human defender is just entirely outpaced.
Completely outpaced.
So, if the human is outpaced and these self-executing bots can bypass our traditional tripwires, how do we actually defend the ecosystem? What does the roadmap for fighting back look like in this report?
Well, the Forrester Report provides a very specific framework for that. They argue that to curb these rapid losses, businesses have to implement dedicated fraud management solutions.
Okay.
And they divide these into two distinct categories: technical defenses and non-technical defenses.
So what does this all mean? I want to dig into that division because, frankly, my initial assumption is that if we are facing a highly technical algorithmic threat, the only logical response is a highly technical defense, right?
I think so.
Yeah, like we need to build a better, faster defense algorithm to fight their attack algorithm. Do we not just need more advanced AI to protect the system? Why does the report explicitly highlight non-technical defenses too?
This raises an important question, because technical defenses are absolutely the baseline. You cannot process data at the speed these malicious agents are attacking without advanced machine learning on your side.
Right, you need AI to fight AI.
Exactly. You mentioned earlier how a human typing a credit card is slow and full of friction. Technical defenses capitalize on that. A fraud management system will use behavioral analytics to measure exactly how a user is interacting with a website.
Okay, so it's looking at things beyond just the password getting typed in correctly.
Much deeper. It measures the trajectory of the mouse cursor. It measures the dwell time, like how many milliseconds the user pauses before moving to the next text field.
Oh, wow. It measures typing cadence too.
Yes, typing cadence is huge. If a storefront detects that a user navigated 3 complex web pages, filled out a 12-field checkout form, and submitted payment in 0.04 seconds.
Which is impossible.
Right. The technical defense flags that as physically impossible for human. It recognizes the machine logic and blocks a transaction instantly.
And I'd imagine this requires immense computing power, which is where specialized AI tools come in.
Precisely.
Okay, so the technical side makes complete sense. We use defensive AI to spot the physical impossibilities of the attacking AI.
Right.
But that brings me back to the second category the report emphasizes, which is non-technical defenses. On the surface, fighting a cutting-edge algorithmic threat with non-technical solutions sounds like bringing a rule book to a knife fight.
It does sound counterintuitive.
Yeah. Why does Forrester place non-technical strategies, which I assume means like manual policies or business rules, on equal footing with software solutions?
Because if you rely exclusively on software to fight software, you are trapping yourself in a perpetual arms race.
Ah, the attacker builds a better bot, so we build a better firewall, so they build a better bot.
Exactly. And in that arms race, the attacker has a massive advantage. They only need to find one single logic flaw in your technical defense to break through.
Just one.
Just one.
Yeah.
And because they operate at machine speed, once they find that single flaw, they could exploit it 10,000 times a minute before your engineering team even realizes the firewall needs patching.
That's terrifying.
It is. Technical defenses are brittle if they stand alone. That is why non-technical defenses are critical. A non-technical defense doesn't try to outcalculate the bot. It changes the economic rules of the game.
Oh, I see. This reminds me of how physical security works. Like if you are building a bank, you install the high-tech alarm system, right? You have the laser grids, the motion sensors, the digital keypads.
Right, that's your technical defense.
Exactly. But you don't stop there. You also implement a non-technical defense, like a strict policy that the main vault requires two different bank managers to insert two physical keys at the exact same time before it opens.
Yes.
The alarm system is designed to catch the speed of the break-in. But the policy is what actually prevents the catastrophic loss of the money.
That is an excellent way to frame it. You're using structural policies to dictate the terms of engagement. Let's map that back to the restaurant reservation bots we talked about.
Okay.
We established that the technical defense might look for an IP address, making requests too quickly. But a smart malicious agent just spoofs 1,000 different IP addresses.
Right. It routes itself through servers all over the world to look like 1,000 different people booking tables.
Exactly. So the technical defense fails. But what if the restaurant implements a non-technical defense? What if they change their booking policy to require a non-refundable $20 deposit just to hold a table?
That changes the math completely.
Completely. The malicious bot is perfectly capable of bypassing the IP block and navigating the booking form. But the scammer running the bot doesn't want to actually spend $20 of real money for every fake reservation.
No, because they might not make it back.
Exactly. If they instruct the bot to hoard 1,000 tables, they suddenly have $20,000 in sunk costs, and they might not be able to resell all those tables. The non-technical policy breaks the economic model of the fraud. It introduces artificial friction that ruins the attacker's return on investment.
That makes perfect sense. The bot is fast, but it can't outrun a bad business model. Are there examples of this in the e-commerce space too, like where physical or digital products are involved?
Definitely. Consider the purchase of digital gift cards.
Okay.
That's a favorite target for malicious bots because the delivery is instant and the asset is super easy to launder. A non-technical defense would be a store policy instituting a mandatory 24-hour holding period on the fulfillment of all digital gift card purchases.
So regardless of how quickly the transaction was approved by the credit card processor, you wait.
Exactly. So even if the attacking algorithm successfully bypasses the behavioral analytics, mimics human mouse clicks perfectly, and uses a stolen credit card to buy $1,000 in gift cards,
They don't actually get the cards.
they don't get the cards for a full day. And that 24-hour window is critical. It provides enough time for the actual human victim to wake up, check their email, see the fraudulent receipt, and call their bank to issue a chargeback.
It dictates the pace of the fallout.
Yes. The malicious agent is designed for instant smash-and-grab operations. By implementing a non-technical holding policy, the business denies the attacker the instant gratification their entire model relies on.
You are intentionally reintroducing the friction that the AI was originally designed to eliminate.
Yes, exactly. A truly robust fraud management solution has to be a hybrid. You blend the software guardrails, the technical defenses that process data at high speed, with structural non-technical rules that remove the incentive or the capability for runaway damage.
You design the ecosystem so that even if a self-executing code slips past the AI sensors, it immediately slams into a brick wall of policy.
Spot on.
Well, this has been a deeply illuminating look into a very complex, fast-moving space. To synthesize the core takeaways from the Forrester Report for everyone listening, we are entering a highly convenient era of business to AI.
We really are.
Digital agents will increasingly handle the friction of our daily lives, from scraping the web for the best price on groceries to interfacing with booking APIs so we can get a table on a Friday night.
But that same automated ecosystem is exactly what enables the runaway malicious AI agent. The same technology that makes shopping instant makes theft instant.
Right. And because these autonomous threats lack human physical limitations, they can execute thousands of microtransactions, bypass traditional volume caps, and cause immense financial losses before a human analyst even registers the attack.
It's a daunting reality.
It is. And to defend against this, organizations can't just rely on an endless algorithmic arms race. They have to implement layered fraud management solutions, utilizing advanced technical tools for real-time detection, backed by non-technical policies that disrupt the economic incentives of the attackers.
You know, it forces us to reconsider what our digital landscape is actually becoming.
What do you mean?
Well, We started this deep dive talking about the very human element of getting scammed, right? The pickpocket, the hacker at a keyboard. But look at the trajectory we've just outlined. If autonomous digital agents are increasingly the entities making our purchases and interacting with storefronts, and if highly advanced AI systems are the entities analyzing behavior and defending the gates against malicious bots.
Where does the human fit into this picture?
Exactly. Are we rapidly approaching an e-commerce ecosystem where humans are entirely cut out of the loop? It raises the possibility that we are destined to become mere bystanders. We might just find ourselves sitting back watching our bank accounts while an invisible high-speed digital battleground of algorithms buys, attacks, and blocks each other in the background.
Just machines fighting machines.
Right. The pickpocket is code, the security guard is code, and the shopper is code. We merely provide the capital.
That puts a completely different spin on the idea of automated convenience, something to really think about. Thank you for joining us on this deep dive into the evolving mechanics of AI commerce fraud. We will see you next time.
You've been listening to What the F Happened? Fraud and Financial Crime Deconstructed, a Defend podcast by DataVisor. If you want to keep learning between episodes, check out Defend Training, a set of self-paced online courses for fraud and financial crime professionals, practical and built around real-world scenarios.
And you can earn CPE credits through the ACFE San Francisco Bay Area chapter. You can find it at datavisor.com/defendtraining. The link's in the description.